In this lesson, we will learn how to find the standard deviation and variance of a set of data, as well as interpret the standard deviation. A very common measure of spread that you will see is called the standard deviation. The standard deviation of a set of data is the average distance a data point is from the mean. This sentence could be one of the most important things you learn in this course. Some of you might be familiar with formulas or numbers, or maybe this is the first time you've heard of this word. However, there are two huge ideas that are associated with this word: the calculation and what that calculation represents. They are directly tied together. So let's start by looking at the definition. The standard deviation of a set of data is the average distance a data point is from the mean. Now let's connect this definition to the formula. Mathematically, it looks a little intimidating. Honestly, just like the mean, I don't think about the formula with all the symbols. I think about what each part represents. When I look at the x sub I minus x bar, x sub I means any piece of data in my set. If I take any piece of my data minus x bar, which is the mean, then I'm finding the difference between my number and the mean, or the distance away, which is part of the definition. Now I take the summation sign, which means I add those up. And for some reason, I have to square and a square root. I'll talk about that later. Then I have to divide by something. If I'm taking an average, I usually divide by how many pieces of data there are. Well, for us to find the standard deviation, we will divide by n minus 1. The reason for this is that we treat all of our data sets as samples. When finding the standard deviation of a sample, we divide by n minus 1. If it was a population, that's a different story. Symbolically, standard deviation of a sample is denoted by an S, and a population standard deviation is noted by the Greek letter sigma. Just like when we were talking about means, we had an x bar and a mu. Standard deviation has an S and a sigma. The Greek letters are for when we're talking about population parameters. The S and the x bar are when we are talking about a sample. Now suppose my data set consists of all the same values. So I have a 10, I actually have 5 10s here. What's the standard deviation of my data set? Well, think about what the definition is. On average, how far is any data point away from the mean? Well, the mean of my data set is 10. What I'll do is I'll close my eyes and I'll pick a number. I happen to pick a 10. I'll ask myself, about how far away is my value from the mean? Well, my mean is 10, so how far is my value from 10? It's 0. Let's try again. Close my eyes, I pick another number. It happens to be 10 as well. How far away is this data point from the mean? Also 0. Well, if you think about it, in this particular data set, if I kept doing this over and over and over again, every distance will be 0. So the average distance any data point is away from the mean will be 0. So the standard deviation for this data set is 0. Now let's consider a different data set. Here we have 15, 10, 20, 5, and 30. I have all the numbers you see on the screen. All right, I'll close my eyes, pick a data point. On average, how far is 15 away from the mean. But wait a minute, I haven't calculated the mean yet. I could use my calculator, or I could do that in my head. For this data set, the mean is 16. So on average, how far is 15 away from 16? Well, it's 1. Okay, keep that in mind. Now I'm going to pick another one. 10. About how far is 10 away from 16? Well, that's 6. Now I have data points that are 1 away and a data point that is 6 away. I'll pick another one. 20. That's 4 away. So now I have 1 and 6 and 4. So on average, how far is each point away from the mean? Well, that's not quite as intuitive as when all the numbers were the same value. Now I'll give you the exact value for the standard deviation of the data set 5, 10, 15, 20, and 30. What is the standard deviation? Let's do this by hand. Most of the time you'll be using a calculator to do this, but I think it's important to do it a few times by hand to really understand what standard deviation means. The best way I found to do this is by making a chart. Our first column on our chart is our numbers and our data set. Standard deviation is the average distance from the mean. We need to find the distance of each of our data points from the mean. First, we'll find the mean of the numbers, which is 16. In this column, we'll take 5 minus 16, 10 minus 16, and so on. We'll get negative 11, negative 6, negative 1, 4, and 14. If we were to find the average right now and added this column, we'd always get 0. What we do in stats land to combat this problem is to square everything, because all of these numbers will now be positive. By doing that, we get 121, 36, 1, 16, and 196. Now, if we want the average distance, we add up this column, which equals 370. And usually, we would divide by the total number of data points. But we're assuming that this is a sample. And whenever we're finding the standard deviation of a sample, we'll divide by 4 in this case, which is the number of data points minus 1. Always divide by how many data points there are minus 1. If we do that, we get 92.5. Now that doesn't really seem right. The average distance from the mean is not 92.5. That's because this is not the standard deviation. This is what we call the variance. Remember over here when we squared the column? We have to undo that. To undo that, we use the square root. If we take the square root of 92.5, that will be our standard deviation. Therefore, our standard deviation for this problem is about 9.87. It is labor intensive, but I want you to do it a couple of times so you get the idea of what standard deviation is all about. Now this is how it looks all nice and pretty, but we get the same answer, approximately 9.8. If I wanted to find this on a calculator, I need to put the data in my list and go back to one var stats. Let's do it. I'll take the same data that we used in this example and put it into the calculator. I already have data in list 1 and list 2. I'm not sure if I'll need that later, so I'll just use list 3. I'll put in my data, 5, 10, 15, 20, and 30. I want the calculator to find the standard deviation. Where do you think I go to calculate standard deviation? Right, Stat, Calc. Press Enter. But remember, my data is in list 3. Let's calculate that. Good news, it gives us our standard deviation. It actually gives us 2 standard deviations. If you look on the calculator, there's an SX and there's a sigma x. We will always use SX. Now, why S and not sigma? S assumes the data that you input into the calculator is from a sample. Sigma assumes that it's from a population. As I said earlier, we are always dealing with sample data. Hence why we use S and not sigma. And what really is the difference? Well, in that formula, S divides by n minus 1, whereas sigma is divided by n. As you can see in the formula, there's an n minus 1 there. It shows you that we're dealing with the sample data. If it was just n, I would assume it was a population, which we usually never have. Now, as I mentioned, when we are doing this example, variance is another measure of spread. It really is just the square of the standard deviation. Before you square root, right at the very end, you get 97.5. That number is the variance. After you take the square root, that's the standard deviation. So far, we have a few important symbols that I want to make sure we go over again. Standard deviation will either be sigma or S. Variance is sigma squared or S squared. It doesn't even get its own symbol. And mean is mu or X bar. Now let's try another example. In example 2, find the standard deviation of the 10 test scores from a unit test in an English class. I'll give you a few minutes to try this one on your own, maybe using the chart to help you, and then we will continue. Pause the video to write down your answer, then hit play to continue. Here's the solution to example 2. Looking at your chart, you might have something that looks like my solution, where you have a column of x minus the mean, and then the squared column. You add it up to get 2,788. You divide by 9, and then you take the square root. And that gives you 17.6. You should also know what standard deviation represents. In other words, I want you to interpret the standard deviation. From the last example, we saw that the standard deviation was 17.6 for the English scores. Now, what does that really mean? Well, this means that on average, a student scored about 17.6 points away from the mean. Now let's test what you've learned so far with a check for understanding. Here is a sample of 10 women's ages when they had their first child. Calculate the variance and the standard deviation. Pause the video to work on this. Click play when you're ready to move on. Here's the solution to this check for understanding. The variance is approximately 18.1, and the standard deviation is approximately 4.25. Now that we've calculated the variance and standard deviation, let's go one step further and interpret the standard deviation. Go ahead and pause to take some time to do this. Click play when you're ready. All right, so let's take a look at the solution to this question. On average, a woman will be 4.25 years away from the mean, which is 29.1 years old, when she has her first child. What's in red there is the structure you'll want to use when you interpret standard deviation. Now it's time for the wrap-up. After this lesson, you should be able to do the following. Find the standard deviation of a set of data, find the variance of a set of data, and interpret the standard deviation. That concludes this lesson on measures of spread called standard deviation. Remember, you can review this video as many times as needed for better understanding. Thanks for watching.